Good morning. Our topic for today is moment area method of a simply supported beam, a determinate beam, with a concentrated load of 12 kilonewtons, 1 meter from the left reaction, from the left support. Our required is slope at A and the slope at B and the maximum deflection, while EI is constant. The first thing we'll do is solve for the supports. So to solve for the supports, we sum moments at point A to eliminate RA. So RB times the distance is 3 meters minus 12 kilonewtons times its distance 1 meter. So the resulting reaction is 4 kilonewtons. To solve for RA, we simply need to sum forces vertical. So RA plus RB minus 12 is equal to 0. So RA is equal to 8 kilonewtons. The next step is to draw the moment diagram. First, we need to assume a fixed point. So in this problem, I assume the fixed point at point B. So RA will be 8 times the distance at point B is 3. So 8 times 3 will give us 24 kilonewton meter. And here at the concentrated load, 12 kilonewtons times 2 meters the distance at B. So it will give us negative 24 because it's the opposite direction, negative 24 kilonewton meter. Note that here 24 and negative 24 cancels out, so that means moment at B is equal to 0 because it's a roller support, so our assumption is correct. Next, the next thing we'll do is to exaggerate the deflection here, just like here, there. Exaggerate there, and we'll draw a tangent there. So this will give us the deviation from A to B, A to B. So we'll need to solve for the deviation at point A to point B. So the formula gives us the area from A to B here, this area, times the centroid. Knowing that the centroid of a triangle is 1/3 or 2/3 based on its reference point over EI. So it's 1/2 base 3 meters here, 3 meters. Wait. 1/2 base 3 meters times 24, its magnitude. And the centroid, okay, the centroid is 1/3 from the reference point B, 1/3 of 3 here, 1/3 of 3 here, okay, plus the negative magnitude 1/2 times negative 24 times 2 here, the base of here. Then the centroid of 1/3 times 2. The deviation at point A to B will give us 20 over EI, kilonewton meter cube. So to solve for theta A here, note this angle here is equal to the angle here because of the property of vertical angles. So theta A here is also theta A here. Okay. So to solve for theta A, we need to use trigonometry using tangent property. So tangent theta A is equal to opposite dev deviation divided by the adjacent side, which is 3 meters. So that will, but take note, theta is equal to tangent theta if and only if theta is a relatively small number or has a small value. So substituting theta A is equal to 20 over EI, that's the deviation, divided by 3. So that will give us 20 over 3I kilonewton meter squared, because the meter cube, meter cancels, so meter squared. Okay, next. The next thing is to solve for the deviation at point B to A. It's the same thing as we did at deviation from A to B. So we'll just repeat area. Oh, I forgot the EI here. So this is over EI. So we'll just repeat the solution. So 1/2 base 3 times 24 magnitude times, take note, this is 2/3 because our reference point is at point A. So the centroid of the triangle is 2/3 of 3 plus the negative area 1/2 times base 2 times negative 24 magnitude times 2/3 times 2 plus 1. This is 2/3 times 2 plus 1 because here, this is the magnitude, this is the centroid. So this is 2/3 of 2 plus this distance here is 1. So we're gonna add it because our reference point is at point A. Okay. So that will give us the deviation from B to A is 16 over EI, kilonewton meter cube. So similar to theta A, tangent theta B is also equal to theta B is equal to the deviation from point B to A over 3, the distance. So substituting 16 over EI over 3 will give us 16 over, wait, 3 EI. There's a mistake here, so I'll just edit it. 16 over 3 EI kilonewton meter squared. Okay. The next step will be to solve for, now we solved for theta A and theta B. Now we solve for the maximum deflection. So before we could solve the maximum deflection, we need to assume its location from the beam. So I assume the location will be here after the concentrated load here. Because this is our deflection and this is our maximum deflection. Doing the earlier stages, I drew again a tangent here. So the deviation from A to B will be in our equation. So this is our maximum deflection. So we need to solve first for the deviation from A to C. Wait, before solving the deviation from A to C, We need first to solve the distance from A to C. I I indicated C here. I assume that's point C. Okay. So we need first to determine this distance. So I'll just call it X. And we all know that this is 1 meter. So this distance, unknown distance, will be X minus 1. So for the magnitudes of the triangles, I just multiplied 8 times X. So here is the magnitude. So here, the magnitude will be 12 times X minus 1. So here, negative 12 times X minus 1. So doing that, we can solve for the value of X by using this formula. Theta A is equal to area AC, area of from A to C over AI. We have already solved theta A, so that's 20 over 3AI. Then we just substitute 1 half 8x times x plus 1 half negative 12 times x minus 1 times x minus 1. So that will give us, EI will be cancelled because it's in our both equations. So substituting and shift solve, we come up with x is equal to 1.367 meters. Then we can determine this magnitude 8x and this magnitude here. So the value would be 10.936 kilonewton meter and negative 4.04 kilonewton meter. Okay, next. Now we can solve the deviation from A to C. So it is equal to the area from A to C times the centroid to point C over EI. So we just need to add the areas. 1 half, this is the magnitude of the triangle a while ago. 10.936 times x, this is 1.367, times the triangle is, here is the centroid and this is point C, point A. So it is one third of x, one third of 1.367 plus 1 half times the negative magnitude 0.404 times, this is x minus 1, the distance. So 0.367 times the centroid. One third of 0.367 over EI, and that gives us 3.307 over EI kilonewton meter cube. Okay. Lastly, we can now solve for the maximum deflection. I drew here the triangle, what we drew in the beam, the triangle. As you can see, these triangles are similar triangles, so we can use the ratio and proportion to solve for y max, because we already know the deviation from A to C and the deviation from A to B, and this is the distance is 3 meters and 1.367 the x. So the deviation from A to B is 3 meters, while it is equal to maximum deflection plus the deviation from A to C over 1.367, the x value we solved earlier. So substituting all the values, maximum deflection will be 5.806 kilonewton meter cube over EI. Thank you. That's all.